Looking at chapter 5 section 1, we're going to talk, starting to get into trigonometry now. So first we need to look at angles and some just basic terminology. When we're looking at angles, we're looking at two rays. So we're looking at two rays sharing a common endpoint. Right, that endpoint is called a that's a YS. That endpoint is your vertex, right? And so we have on our rays, the one side is called our initial side, and then we open it up, and if we open it up counterclockwise, so right here it's opening up counterclockwise, and where we end, that's called our terminal side, and our vertex is where we have that common point. And then positive angles, like I said, open clockwise, where negative angles open down, so they open clockwise. Okay, so that's kind of the main terminology of our trigonometry. Now we can get into talking a little bit about measures and degree measures. So the angle measures are in degrees. We'll get into later about radians. So there's kind of two different ones. There's degrees and radians. You can see that on your calculator. Just so make sure when you do use your calculator in this chapter, and that you know if your calculator is in degrees or in radians. Another thing about angles is when I label them, I can label them with Greek letters, right? Alpha, beta, theta, as well as I could do capital letters A, B, C, D, and so forth. So that's kind of how you label angles, and their measures are in degrees or in radians. And remember that 1 degree is equal to 1 over 360 degrees, or 360, not 360 degrees, right? Because 360 degrees is one rotation, so 1 degree is 1/360th of a rotation. So 1 degree is equal to 1/360th of a rotation. Okay. And then so that means 360 degrees would be 1 full rotation. So now let's look at some other type of angles that we have. We have an acute angle, right, less than 90. This is theta here. It's just representing an angle. I could have used A, could have used B, anything like that. So if I have an acute angle, it's between 0 and 90. If I have a right angle, right, notice by this little box, then my angle is 90 degrees. I have an obtuse, my angle has to be greater than 90, and I have a straight line, straight angle, which is 180 degrees. Then we have some other types of angles, complementary angles. So complementary angles mean that two angles that add up to 90 degrees. So like here is pictured, I have a right angle here in black, so that means if I have some angle cutting through here, that this angle and this whole angle this angle alpha from here to here and this angle beta from here to here, those together would equal 90. So that means that beta and alpha are complementary angles because they add up to 90. Now they don't have to be connected like that. I could have an angle like this, and I could have another angle like this, right? And those two together, this could be 35 degrees, and this could be 55 degrees, right? And that would be those two angles would be complementary, because if I added them up, they would equal 90 degrees. The other type is supplementary. So supplementary angles add up to 180, right? And again, they could be two separate angles. They don't have to share a common ray. They don't have to share a vertex, right? They just have to be two angles that add up to 180. So this alpha and this beta would add up to a straight line, right? So here's a question. What is find the complement of 60 degrees? So what plus 60 is 90? That's 30. So the complement of 60 is 30, because 30 plus 60 is 90. Find the supplement of 130, 135. So what do I have to add to 135 to get to 180? Well, uh, if I add 5, that's going to be 140. So add 40 more, that'd be 180, right? So 45 degrees is the supplement of 135. So here is a couple examples, right? Here I want to find out what my value of each angle is. So first I have to find the value of x. So here I have a right angle. So that means that this angle and this angle are complementary. So that means if I add them together, they would equal 90 degrees. So I can simplify and I can solve for x. And then I plug x back in. So this angle is 30 degrees, and this one then has to be 60 degrees. Same thing here on this one. I have a straight angle here. So that would be 180. So that means this one plus this one would equal 180. So I have to add them together. So I get 10x plus 1 equals 180. Subtract 1, I get 179. So that means x would equal 17.9. And now I can plug in 17.9 and times it by 6. And I get 107.4. So if I add 0.6, that'd be 108. Add 2 more, that'd be 110. So 2.8 would be 110. And then I need 70 more, right? So 72, this angle over here is 72.8. All right. So that's how you can find those. So these examples would be on page 481, number 1, 3, and number 15. But we're going to do a couple more examples here and get into degrees, minutes, and seconds. So degrees, minutes, and seconds is just another way to calculate degrees. Okay, so you have kind of two different forms of degrees here. You have degree, minutes, and seconds, which is used in traditional forms like maybe dealing with GPS or maybe something like that. So this is very similar if you want to think about this as hours, minutes. So hours, minutes, and seconds, right? Because in 60 seconds is 1 minute, right? So in 1 minute there's 60 seconds, and in 60 minutes there's 1 hour. So that means in 1 minute would equal 1/60th of an hour, right? And 1 second would equal 1/60th of a minute, and 1 second would equal 3,600th 1 over 3,600 hours, right? That's what 1 second would be. Okay, well, all we're doing really is just changing this hours to degrees, and it still has the same ratio. So in 60 minutes that's 1 degree, right? So 60 minutes is 1 degree, or 1 minute is 1/60th of a degree, and in 60 seconds there's 1 minute. Same as saying in 1 second there's 1/60th of a minute. Now degrees has our degree symbol. A minute is labeled with apostrophe, and the seconds is 2 apostrophes. So we have a degree symbol, apostrophe for minute, and the parenthesis for seconds. And so it's just like the conversion of hours, minutes, and seconds. There's 60 seconds in 1 minute. There is 60 minutes in 1 hour, same as degrees, and there's 3,600 seconds in 1 hour. Right, so it has the same conversion. So in order to calculate to degrees, minutes, and second form, what you want to do is the degrees will stay your degrees. Okay, then whatever your minutes are, you divide that by 60, because there's 60 minutes in one degree. And then you'll take your seconds, however many seconds you have, and you'll divide that by 360. Because what you're trying to do is you're converting you're actually converting from degrees, minutes, and seconds to decimal degrees. So what we're actually trying to do is we're trying to turn this into degrees and this into degrees. Okay? So we already have 12 degrees, so we don't need to mess with that. Now we need to turn 42 minutes into degrees. Well, every single one of these minutes, right, is 1/60th of a degree. So if we divide that by 60, we'll find out what is 42 minutes. How many degrees is 42 minutes? That's really the question that you're asking. So if you take 42 and divide it by 60, that means 0.7. Okay? We'll go ahead and we'll be adding these. So 42 minutes is 0.7 degrees. And then 38 seconds, I want to divide that by 3,600 because I'm trying to find out how many degrees 38 seconds is. And that is 0.010, we'll go 6, we'll round that at the end. Now we just add these together, right? So we get 12.7106 degrees. So we're switching it to decimal degree form. All right, now we can perform this operation of adding. So we want to add these. Well, in order to add them, it's kind of like decimals where you have to line it up, right? If I have 12.37 and I have, plus 3.2, and I line my decimal underneath my decimal, right? So I put the 3 here and the 2 here, right? So same kind of thing. I want to put my degrees underneath degrees, and I want to put my minutes under minutes and seconds under seconds. So here I'm fine. Now I can go ahead and actually add these, right? So I can add how many minutes there are. So if I add these minutes, I get 9 and 6, right? 5, carry the 1. You can do this long way or short way, whatever you want to do. But here, whenever I go over 6, right? Because if I go over 60, that means that I'm really that is another degree, right? So 1 plus 2 is 3, it's 7, so there'd be 7 here, but I went over 6, right? So when I go over 6, I carry that 1 degree over, and so really, I'm only going to have 15 here, right? Because this right here adds up to 6, and that 6 is going to be 1 degree, because that's 60, that's in the tenths place, right? So that's really 60, so I'm going to add that to my degree, so then I have 1 degree, 2 degree, and 5 degree here, and then 5 and 8 is 13. So this would be 135 degrees and 15 minutes. Okay, so maybe that sounded real confusing. Well, just go ahead and add 51 and 83, that's 134, so 134 degrees. Go ahead and add 29 and 46, that's 75 minutes, right? Oops, 75 minutes. Okay, well, in 60 minutes is 1 degree, right? So that means 60 of these, I can just add 1 degree. Well, what's 60 minus 75? There's left over, right? Of this 60 that I'm taking out, there's left over 15 minutes, because 75 is equal to 60 plus 15, and this 60 is 1 degree, right? So that 1 degree is going to be added 134, so I get 135 degree and 15 minutes. So that's kind of simplified form there. All right, then you can convert this going backwards. So I'm going to put this in degree, minutes, and seconds form. So instead of dividing by 60, right, I'm going to start multiplying by 60. So 34, that is how many degrees I have. So then I just take this decimal and multiply it by 60. Okay, and that's going to find how many minutes I have. Okay, because I'm after degrees, minutes, and then seconds. So if I multiply this 0.817 by 60, then I'll get how many minutes, which is 49.02. That's how many minutes there are. Okay, but then I take this decimal, 0.02, and I times that by another 60, because this is minutes, and I want to figure out how many seconds, right? And there's 60 seconds in 1 minute, right? This is minute. Oops, minute. And I'm trying to figure out how many seconds there are. So if I times 0.02 by 60, I get how many seconds? Which is 1.2. So if I just round, I get 1 second. So that's my answer going back into the different form. Okay, and so that's pretty much it for that. I'll go ahead and work through some problems on the next video, and I'll just add it to it. So some of the problems that you'll be working on, like I said, at 1, 1, 13, and 15, and then 37, 41, 53, and 63. So that's kind of all those examples that I did on page 481. So you can practice those problems, and I'll go ahead and do these on a separate video.